Welcome to our course of Autodesk Robot Structural Analysis Professional. Intermediate level, for reinforced concrete structures. Part 2, for seismic analysis and foundations. Okay, let's begin. This time, we are going to dedicate this course to one of the most common elements required by every engineer and architect out there. The construction of small projects of reinforced concrete structures, which at the same time, utilizes infill walls, that might be either masonry, or concrete walls. But also, walls made of drywall panels, and wood, with insulations. So let's see how we could solve the case of a structure as typical as this one. That nevertheless, involves a certain degree of difficulty, that is to say, if you observe this project that was with us in the course of Autodesk Revit, it presents a series of projections that goes between 9 and 13 feet, depending on the zone. Projections, which are in cantilever. Namely, that they are not supported in all their extremes. Now, the fact of placing these elements, that might be very simple, but that involves some degree of difficulty, will be a perfect motive for analyzing a structure such as this. That also, you might interpolate to any other type of project. This time, in this tutorial, in this second part that is, we are going to see also the analysis for the foundations. From now on, we are going to assume that all the structure is made of concrete panels, reinforced concrete walls. Therefore a reinforced concrete structure. And this is going to be supported by foundations that will be following the whole perimeter, giving support to the bearing walls. That is to say, that the whole weight of the structure is going to be transmitted through the walls, that could be either of masonry or reinforced concrete, and that are going to be evenly supported across the foundations, that will be composed of a concrete slab and a corresponding beam, that are going to evenly distribute the whole load of the project over the terrain. Also, we are going to consider the structure, the slabs, and inclined slabs. And overall this approach, we are going to place a series of load cases and combinations. We are going to begin from the dead load. And here we are going to make the next consideration. Whether you have created the project in Autodesk Robot, or imported this from Revit Structure, Robot is going to consider by itself the weight of the structure, depending on the material we've specified. For instance, if you specified masonry walls, Robot will take that into consideration regarding the weight of the structure, and so on, if you determine reinforced concrete walls instead. Or even if you are going for a steel, or a completely made out of wood structure, Robot will take all that into consideration, and place the whole weight of the structure over the foundations, without us needing to calculate element by element. Good. We are also going to consider the live loads. And for the live load, we'll have the advantage of establishing this by our own criteria, and in an evenly fashion over the slabs, over which we are going to consider a traffic of residents, or even some elements part of the furniture, or the equipment that this structure might have. But also, we are going to assume even more things. We are going to pretend that this structure is in an exposed area, perhaps next to the coast, where the wind gusts are severe, and where the wind is going to be an important load over our structure. So we can see how this forces affect such structure. In this same way, we are going to consider that these slabs are going to accumulate snow, which of course is an overweight, or additional weight that we have to consider in all of our structures. Since if we neglect this, we might experience a collapse of our structure during any sort of heavy rain or hail. Good. We are also going to consider accidental loads. That's to say, some loads or stresses that accidentally fall upon our structure. Now, the most important thing for us will be the seismic analysis. Although is to mention that at least in this particular course, we won't go far too depth into this subject, since for that, we have an advanced level course, in which we'll consider a seismic analysis in a structure of several floors. However, what we are going to see are those analyses that correspond to a small structure, such as this, and also which seismic considerations you should do if you are building in a seismic zone, and also how you should present it, for Autodesk Robot to make an adequate consideration. Good. Once we have all the cases and the proper combinations, for both the ULS and the SLS, and really, for all the combinations that we might have by regulation. Because let's remember, that Autodesk Robot is a software that follows the regulations. For instance, in this particular case we'll be using the ISA code. However, we are also going to briefly mention some other regional construction codes, for our friends that might be outside of America. Also in this regards, this tutorial will be taken in two systems, one that is going to consider kips, and another that will consider meters and kilonewtons. All this of course, so you are able to see examples, in both the metric, and the imperial system. Good. Once we have placed all these load combinations, we are going to ask Robot to show us the results. And for that, we are going to click here, and ask for the result diagrams. And, we are also going to reconfigure the screen. Good. Here we have the screen properly configured. Now, as you probably know already, and as you saw in our previous course, Robot is a software in which you have to navigate through all the design and calculation options, and that means that you should know how to access each of them. And because of it, we'll be spending a few moments on letting you know how to properly configure and arrange each screen, so you can easily access each consideration of design and calculation. And you can navigate them without getting lost, or losing important data. Good. Here we are again, in the area of graphs. And this is the first part of our graphs, in which we can see the shear and bending moments. Here, for instance, I can select all, ask Robot to apply them, and appreciate the magnitude of all the stresses that I've selected. But also, as you know, I could select one single element, or frame, isolate it, and begin its corresponding analysis. Let's adjust the view. And eliminate the thickness, so we can appreciate everything more easily. So for instance, for all my combinations, I could see all the deformations. Let's apply them all. However, let's delete first the previous ones. And let's select them all again, and apply them. And now, we'll be able to see all the deformations, according to all the different load cases that we might be applying to our model. Basically, what we have seen already in our previous tutorial. Now, here we can see the stresses, the reactions, very important now, since we intend to calculate the foundations. So it's very important that we can know the reactions on the extremes, in order to design adequate foundations. Robot will allow us to design foundations according to our needs, either if we are using isolate or stripe footing, that is, a slab and a beam that allow the weight of the structure and its efforts to rest evenly over the terrain. And well, we are going to have several type of considerations. Also something very interesting, is that we'll be able to see the graphs for the map results. Over what it could be the slabs of our project. Also, we are going to make some considerations over the slabs, as well as the related stresses that could exist in direction of the slabs, that above all, are designed in two directions. Good, all this type of things, are what we are going to observe. And once we have completed all these analysis that we have to see, such as seismic, wind, slabs and beam analysis, we'll always be able to do something interesting. For instance, if we return now to the view of this frame. Let's choose a front view. Turn off the slabs. And now select one of the elements. For instance this panel. And let's now subject it to a test. For example, I want Robot to tell me how I should assemble both the panels and columns, and suggest me the right reinforced concrete elements. So here for instance, we have the design of the foundations. And well, we could arrange this window a little bit more evenly, and show now for example, the design of the reinforced concrete for this foundation system. Here, we can also see it in an isometric view. But more importantly, the specific design for the reinforced concrete of this system. However, as we had previously mentioned, at this level, is not necessary that we pay too much attention to this matter. Since at the criteria of the structural engineer, we could add stirrups, bars, etc. and ask robot to run a test, and finally obtain the calculation note about how this foundations are getting solved, what the criteria was, the stresses and the graphs that are being followed. That is then, what could correspond to the foundations. As for one of the reinforced concrete beams that exists in the second level, as we saw in our previous tutorials, we can make several considerations and adjustments. For instance, here we have robot suggestions, but we could always access these values, and propose a new type of design. This, for example, is the window in which we could add new stirrups, change its distribution, modify the number of bars, or longitudinal steel, also the transversal steel, and finally some additional bars. Since at the end of the day, robot will allow us to test this proposed design and obtain all the analysis and safety coefficients that we'll have in our structure. Finally, robot will submit automatically all the corresponding layouts, whatever our design choice and applied criteria was. And with all this, I want to tell you that robot is indeed a great tool, but it never replaces the criteria of a good structural engineer. Good, we'll be waiting for you then, in this second course of Autodesk Robot, Structural Analysis Professional, for seismic analysis. That, like all of our tutorials, you'll have always available on your computer. Watch as many times as you want, whenever you want, and with the help of our experts, through the support center. See you soon.